Alright, doing this problem called longest subsequence with limited sum. Let's have a read. We are given an integer array nums of length n and an integer array queries of length m. Return an array answer of length m where answer I is the maximum size of a subsequence that you can take from nums such that the sum of its elements is less than or equal to the queries I. Okay. A subsequence, yeah, okay, we know what a subsequence is. So in this example, 4, 5, 2, 1, the queries are 3, 10, and 21. So 3 is, that means I want to take a subsequence from this whose sum is less than or equal to 3. So I want to take the largest length and minimize the sum, essentially, right? So I want to keep as many elements as possible, so I'll always start with the smallest element. So first I'll take 1, then I'll take 2, and I get answer as 3. And so for 10, I'll take 1 plus 2 is 3 plus 5, 8, and that's exactly I can take. And then 21, for that I can take the entire thing. So for every query, I am taking the smallest element first, then the second smallest element, and the third smallest, and so on. So I need to sort the array. That's one thing. And then within that sorted array, and so that by sorting, I know the first, the smallest, and so on. And then after that also, so one bit is I sort the array. The other bit is now when I take 3, I can go linearly, like I can do 1 plus 2 plus 5, but or I can maintain the cumulative sums. That if I maintain the cumulative sums, then I just need to search for this guy in that cumulative sum array. So what I mean by that is, so first I sort, the array. So then I get the array as 1, 2, 5, sorry, 1, 2, 4, and 5. And then I also maintain, hey, what is the sum I get? So here I get sum as 1, till here I get sum as 3, till here I get sum as uh, is it correct? 2 plus 4, yeah, 3, 7. Oh, yeah, 7. And then here I get sum as 12. Now, if you're saying here I want sum as 3, well, I could do addition here. I can actually search for this 3 within this and here. So that means I'll have to take 2 elements, right? And then when I search for 10, I'll see, okay, I can have only till here, right? Because this is giving me 12. So these many 3 elements would give sum as 12. And 21, I can find the last. And so we get a general idea. So we can do a binary search in the cumulative summary. So let's do this. So just a sec. So first we sort the arrays dot sort nums, and then we convert this array into, or add a new array. Let's convert the same one into a cumulative sum array. So now for I equals to 1, I is less than nums dot nums of I equals to nums of I minus 1 plus nums of I. So converted this array into a cumulative sum array. Now what I have to do is for each query, so for each, so now first let's say in the result array equals to length of queries dot length, and then I equals to 0, I is less than queries dot length I plus plus. We search this query, so we can use arrays or binary search. So int let's call it r equals to, so you get what there is a arrays dot binary search. In the array nums, you are searching queries of I. Now there are two cases, right? One is found and the other is not found. So arrays of binary search, if you look at it, what it represents. So if key is found, r is the index. If key is not found, then the return value is r equals to -1 minus insert position, right? That's how the arrays of binaries is defined. We can write our own as well, but I'm just being lazy. So essentially now so what if your return value is greater than equal to 0, that means it is the found case, in which case you will do result of I equals to, so it's found that whatever index number of elements will be in index plus 1, right? So will be r plus 1, else this is a not found case. In the not found case, return the where you would insert it, right? So you want to return the insert position. So result of I equals to -1 minus r. Now, why this? I would say just look at the not the implementation, the definition of this and what its data value represents. So that's that, and then return result. All right, submit. Okay, so that's done.